Hello students. So now we are going to start with second numerical on composite function. So here we will find out the partial differentiation of composite function and we'll see how to prove the result. So guys, here we have z as a function of x and y, which is given here, where x is a function of r and theta and y is also function of r and theta. So it clearly denotes that it's a composite function. So guys, here we have to find out this given result. So whenever we have a composite function and we want to find out the partial differentiation, that time what we do is we generally, so whenever we have a composite function and we have to find out a partial differentiation of the given function, then what we do is we generally find out the tree diagram, because by using the tree diagram it becomes very easier to solve the given question. So here first of all I'll draw the tree diagram. So guys, here you can see that z is a function of x and y. So here I'll say z as a function of x and y. Next, x is function of r and theta. So here I'll write r, here theta. Y is also function of r and theta. So here we got the tree diagram. Now next part is, let's start with the solution. So guys, if you observe the left hand side, here we have to find out del z by del x, del z by del y. On the right hand side we have to find out del z by del r, del z by del theta. Now this is what the condition in the given problem. So guys, I found over the years that student gets confused that how to start this problem, whether they should start with LHS or they should start with RHS. So today I'm gonna tell you a hint how you should solve such type of numericals. So the best thing is observe the tree diagram. So as I told you in the previous video also, that whenever we find out a partial differentiation in tree diagram, we always take the differentiation of dependent variable with respect to independent variable. So here the dependent variable is z and the independent variable is r and theta. So what is this x and y? So x and y are the intermediate variable. So if dependent variable is z and the independent variable is r and theta, so we are going to find out del z by del r and del z by del theta, because that gives us the relationship between dependent and independent variable. So it means I'll find out the right hand side first. So by finding the right hand side or the values of right hand side, you easily get the left hand side. So let's start. So to find out del z by del r, let's apply the formula, and for that we have to travel the tree from z to r. So there are two paths, one is z to x, x to r, and one is z to y, y to r. So we'll write it down. So here I'll say therefore del z by del r is equal to del z by del x into del x by del r plus del z by del y into del y by del r. So guys, this is the formula of del z by del r. Now let's find out the values. So del z by del x. So you can see here that z is a function of x and y, but guys, z is not defined. So that is why I can't find out the value of del z by del x. Next, we have del x by del r. So to get that, we have to differentiate x with respect to r partially. So cos theta will remain constant. So the differentiation of r is 1. So guys, here we'll get answer as this value as cos theta, this term that is del z by del x as it is. Next, we have to find out del y by del r. Now again del z by del y is not possible because z is not defined. We'll find out the value of del y by del r. So we'll differentiate this y with respect to r partially. So sin theta is constant, will remain as it is, and the differentiation of y with respect to r partially is 1. So this del z by del y term will remain as it is. So guys, this is the value of del z by del r. Now let's find out the value of del z by del theta. So del z by del theta is del z by del x into del x by del theta plus The second path is del z by del y into del y by del theta. So guys, you can observe one thing, that whenever I want to find out partial differentiation, I am traveling from dependent variable to independent variable. Now let's find the value to get del z by del x. Not possible because z is not defined. Del x by del theta, let's differentiate x with respect to theta partially. So r is a constant, derivative of cos theta is negative sine theta. So here we will get negative sine theta, and this del z by del x as it is. Next, del y by del theta, so differentiate y with respect to theta partially, r as it is. So guys, here I have to write r also, so I'll keep r outside. Next, here r as it is, derivative of sine theta is cos theta, so we'll get positive r into cos theta, and this del z by del y as it is, because z is not defined. So guys, we got all the values. Now let's put these two values in the right hand side. So here in the right hand side we want del z by del r the whole square. So we'll find out square of this. So guys, since here we have two terms and we want to find out the square of this, we will apply the formula of a plus b the whole square. So here I'll write it down. So therefore del z by del r the whole square plus 1 upon r square del z by del theta the whole square equal to. So we'll put the values. So here first of all we'll find out the square. So square of this is square of this, it means square of the right hand side. So a plus b the whole square is a square plus 2ab plus b square. So a square will give us, here I'll write down, cos square theta del z by del x the whole square. Next, 2ab, so 2 into cos theta into sin theta into del z by del x into del z by del y. So here I'll write down, that is plus 2 sin theta next b square. So square of this is, so guys, here we got the value of del z by del r the whole square. Now let's find out del z by del theta the whole square and multiply it with 1 upon r square. So value of del z by del theta is this. Now we have to find out square of this and we have to multiply it with 1 upon r square. Now guys, one thing, that here we have r in both the terms, so I can take r outside, and when we'll do the square, so we'll get square of r also. So that square of r will get cancelled with this r square. So we'll not write this r square. So it means now we have the term as negative sine theta del z by del x plus cos theta del z by del y, and we have to find out square of this. So what we'll do is, we'll take positive term first and then we'll take the negative term. So what we'll do, so I'm assuming this term as a and this whole term as b. So this whole term is a and this whole term is b. So I'm getting positive a, that is cos theta del z by del y, and I'm getting negative b, so minus sine theta del z by del x. So it will give us a formula of a minus b, and since we have to find out square of this, it will be a minus b the whole square. So that is nothing but a square minus 2ab plus b square. So guys, I'll apply this formula to find out square of del z by del theta. So a square, that is square of this term, which will be plus cos square theta del z by del y the whole square. Next we have negative 2ab, so minus 2 into this, so minus 2 cos theta sin theta del z by del x del z by del y. So and then we have b square. So square of this is positive sine square theta into del z by del x the whole square. So guys, here I got the expansion of this del z by del theta the whole square, and 1 upon r square is eliminated because here we have taken r square common. So here you can observe that this term is negative and we have the similar term over here which is positive. So we can cancel these two terms, and now from these two terms we can take cos square theta common. Similarly, from these two terms we can take sin square theta common. So let's see what we are getting. So here we'll get cos square theta in bracket del z by del x the whole square plus del z by del y the whole square. Next, similarly, I'll take sin square theta common from these two terms. So sin square theta outside. Inside the bracket we'll get del z by del x the whole square plus del z by del y the whole square. Now guys, if you observe, then we got the same bracket or same terms in the bracket. So if two terms are having some common term, we take it common. So I'll take this del z by del x the whole square plus del z by del y the y square the whole square outside. So here we'll get now let's see what remains in the bracket. So I've taken this term common outside. So from the first term we'll get cos square theta, from second term we'll get plus sin square theta. So here I'll write cos square theta plus sin square theta, and I'm sure that there is some formula which is running in your mind, which is nothing but that cos square theta plus sin square theta is 1. So value of this is 1, and guys, therefore we'll get answer as del z by del x the whole square plus del z by del y the whole square. And guys, now if you observe this LHS, then we got the exact value. So here we have proved the result. So I'm sure that you understood the method. And guys, if you want to learn such more videos on composite function and other topics of engineering mathematics, then keep watching Ekeeda channel. Also tell your friends to subscribe to Ekeeda channel because they can also get benefited through this wonderful videos. Thank you very much.